Day 1, problem 1. In question A, we're asked to write this number into standard form. This number is in scientific notation, and we're asked to write it as a standard or regular number. Okay. To do this, I'm going to first write that number down again, 5.22, and then the times 10 to the negative fifth power part of it. And recall that to change a number from scientific notation to a standard number involves moving the decimal point. Okay? And that decimal point is moved according to whatever the exponent on the 10 is, in this case, negative 5. Now, a negative exponent on the 10 is going to change this number from 5.22 to a smaller number by moving the decimal point to the left. And so if the exponent is negative 5, we're going to move that dot 5 spots to the left. So here we go. 1, 2, 3, 4, and 5. The decimal point is going to end up out here at the beginning, and there's going to need to be some zeros filled in as placeholders. That is going to create the number 0.0000522. And so the number 0.0000522 is the standard way of writing 5.22 times 10 to the negative fifth power, which is in scientific notation. Now part B. This time we are given a standard number and asked to change it to scientific notation. And so here is the number, 0.00452. And to change this to scientific notation involves moving the decimal point so that there is one non-zero digit in front of the dot. So I'd like to move the dot right there so that the digit 4 is to the left of that dot. Okay. To do that is going to mean that the dot will need to move 1, 2, 3 positions, and that will create the number 4.52. And now the times 10 piece, and we need to figure out the exponent on the 10. Recall that we moved it 3 positions, and so the exponent is going to involve a 3. But one more thing, because this is a decimal number, the exponent is actually a negative 3. And so 4.52 times 10 to the negative 3 power is equivalent to the number 0.00452. Now, day 1, problem 2. Part A, solve this equation. And then in part B, check the solution. So part A. Let's start by rewriting that equation. 5 times the quantity x plus 2 is equal to negative 25. Okay. Now, there are a few ways that we could go about getting the variable x alone. First thing I'm going to do is draw a vertical line down through the equal sign. And I want to isolate the letter x. And to do that, we need to remove these other numbers that are on the same side of the equation as the variable x. Now, because this says 5 times this quantity, we can't remove the timesing by 5 using division. And so divide by 5 on the left side of the equation and divide by 5 on the right side of the equation. 5 divided by 5 makes 1. So this makes 1 times the quantity x plus 2. And that is equal to, over here, negative 25 divided by 5 is negative 5. But 1 times the quantity x plus 2 just means that we have 1 x plus 2. Or a short way to write that is just x plus 2. That is equal to negative 5. Now, here is the x term. To get the letter x alone means that we need to remove the adding 2, and we can do that by underneath writing subtract 2. And over on this side, subtract 2. The x can be brought straight down. And positive 2 subtract 2 makes 0. There is a 0 in this position. And that is equal to negative 5 subtract 2 is negative 7. And so we think that the answer for x is negative 7. Now in part B, we're going to check whether that value is the correct number to use for the letter x. And so let's rewrite this original equation, and where the letter x is, substitute negative 7. So 5 parentheses, now fill in negative 7, and then add 2, close the parentheses, equals negative 25. And the question is, does this expression that is to the left side of the equal symbol really equal negative 25? Let's find out if it does. Okay, doing the work inside the parentheses first, we will get 5 times, and in the parentheses, negative 7, add 2 makes negative 5. Does that equal to negative 25? We're wondering. 5 times negative 5 is negative 25. And so yes, the left side of the equation is equal to the right side of the equation. This checks. X equals negative 7 is the correct value for x.